Welcome to MzansiNumerics. Today we are continuing to learn on the different problem types of vertical projectile motion, the concept, and tackling exam question papers. So in the previous video we focused on type 1. So today we are going to focus on type 2. It is a ball thrown vertically upwards and comes back at the same height. So this one, for example, is when maybe you are playing with a ball, and then when you are playing with the ball, if the ball is on your hand, you throw it up, it reaches a maximum height and comes back to the same hand. So this is a problem type 2, and this problem type 2 is related to problem type 3 and is related to problem type 4. How does it relate to the bouncing ball? Bouncing ball are just arcs of a type 2 added together. As you see that the second bounce is less than the previous one, but it continues so on, so and so on. So it's like a ball on your, you throw a ball up, it comes back and bounces on your hand, it goes back again, and it goes back again. So these two problem types are similar. So the way that we understand type 2, it will also help us understand type 4 of the bouncing ball concept. And also it is similar to type 3. How is it similar to type 3? When you look at the type 3, let's say you are on this building. When you are on this building, you throw a ball up, and then when it comes back, you fail to catch it. So this is the height where you fail to catch it, and then it falls back. It falls below the height where you throw it. So this portion here is similar to this one in type 2. So the way that we are going to understand this type 2 when it comes to this portion is the way that you should also understand this portion where you throw a ball up and it comes back to the same height, but here it comes back below normal. So let me clear the working space so that we can go to the concept. So type 2, it is a thrown up and then comes back same height or same level. So here let's use the very same example of you holding a ball and then you throw that ball vertically upwards, then you throw it vertically upwards, and then it reaches a point, and then when it reaches a point, it comes back. So what we have to know is that if you throw it with 5 meters per second, that's the velocity. So as it goes up, the velocity is going to decrease. 3, 2, 1, and then it reaches a maximum height where the velocity is 0, and then it increases again. It increases again. It increases again. So let me do it like this so that it looks the same level. So what you can notice here is that as the ball goes up, it reduces velocity. Velocity reduces, and then to a point where it reaches a maximum height where the velocity is 0. So what is making the velocity to decrease as it goes up is the force of gravity. The force of gravity is pulling it down, as you all know that we are dealing with projectile motion in which the only force acting upon an object is gravitational force. And then because there's only the one force which is acting downwards, the object will accelerate downwards, going down. So meaning that when it goes up, it will increase velocity until the velocity comes to 0, and then it will do what? It will come back again. And notice that there will be 2 points where the velocity is equal. This is like a parabola. It's like a parabola. So the way it goes up, there are 2 points where the magnitude is the same. There are 2 points where the magnitude is the same, at 3 and 4 and 5 and 5. So let's choose direction. If we say upwards, up is positive. So it means that when the ball goes up, it will have a positive velocity, positive velocity, positive velocity until here, and then it will have a negative now because the ball is coming back. So the velocity at the same point or at the same level will have the same magnitude but different will have the same magnitude but different signs of different direction, because in this context signs means direction. So another thing that we also have to learn here is that the point where the velocity is 0 is the maximum height. It's when, because what is making it go up at this point is the velocity. When it is still 1 meters per second upwards, it will use that 1 meters per second upwards until there is no longer velocity. And because there will be no longer velocity, the velocity will be 0. And then that point, the ball will have 0 meters per second, and it will stop in a speed of a second, and then it will come back again. So that where the velocity is 0 is considered as our maximum height. So let's name our variables in this motion. Let's name our variables so that we understand each and every variable associated with this motion. So first, let's name our V initial. So V initial, when you look at the V initial here, when you say 5, 4, 3, 2, 1, 0, and then let's say plus, 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 and then this one will be minus, minus 2, minus 3, minus 4, and minus 5. When you note it, the velocity that it uses to go, that you throw it up, will be equivalent to the velocity that it comes back with. So let's say if you have a ball, and then when you have a ball, you're holding it at your hand, and there's no air friction, and there's no other thing that can interfere with the motion. If you throw up a ball with 50 velocity, it will come back with 50 velocity. So this sign is just saying the direction. So here we see that V final, if we say V initial, if we say up is positive, this one will be positive, an unknown figure. That, and then when you continue to name our variables, let's name gravitational acceleration. Gravitational acceleration, it's always downward. If up is positive, it means down is negative. So when we name it, it's going to be negative 9.8, which is a constant. And then let's name our change in y. Change in y here is special. For example, change in y here, it just in every instant it means y final minus y initial, which is the initial position minus the final position minus the initial position. So when you have a ball on your hand, the hand is your initial position, and then when the ball comes back to your hand, the hand is your final position. It comes back to the same position. So what is the final position minus the initial position? It will be 0 meters. So here displacement is equals to 0. So here total displacement of the motion is equal to 0. Let's take it for example. We say you come from your house, and then when you come from your house, and then you go to the shops, and then when you go to the shops, you come back from at home from the shops. So your displacement is what? Initial position minus final position minus initial position, meaning that because you are at the same place, your displacement is 0. So this distance is going to cancel this distance. So likewise, the distance of going up is going to be cancelled with the distance of going down. So the displacement is going to be 0. But when we talk about the distance covered, that's when it will be different. That's when we'll add the distance of going up and the distance of going down. So that's very much important to understand displacement here. That's why to understand displacement is very much important, because even in the problem type 3 that we are going to focus on the next video, at type 3, And when we say that you throw a ball vertically upwards and then you fail to catch it when you are on the top of a building, and then it comes back and goes down. So it's similar to say that the displacement of this whole motion is the what? Is the height of the building. The displacement of this whole motion is the height of the building. Why is it the height of the building? The distance covered going up is cancelled by the distance covered going down. So this cancelled this one. And then what do we have left? What we have left is the height of the building. So in this motion, we should also note that displacement is final position, which is this one, minus initial position. So it's just the height of the building, which is the displacement. So that's why I say this motion, this part of the motion of type 3, we treat it similar as the type 2, because it's like a ball thrown up and comes back to the same level. Even here, it is thrown up, it comes back to the same level, you fail to catch it, and then that's when the displacement will be covered there. So the here displacement is 0, and then let's continue to name our variables. And another variable that we are going to have here is the final velocity. The final velocity, because now the ball is going down and up is positive, it means that it's going to be negative. But it's going to be negative the same magnitude as this one, because we have agreed that the velocity that it starts with is going to be equal to the velocity that it comes back with. Now, the change in time, this one is also very much important. So the time that it takes, to reach the maximum height, the time from here to here is similar to the time from here to here. So the time that it's going to take to reach the maximum height is similar to the time that is the same with the time it's going to use to come back from the maximum height to here. So when you are given the time for 2 seconds, you know that here it will also take 2 seconds, and the whole motion of the ball is going to take 4 seconds. So that's why I was saying that we treat this one as a parabola. Just take it maybe as a midpoint of a graph. It's like a midpoint of the graph. So the time here, we don't know it. There's no sign because it's a scalar quantity, but we must know that the time it uses to go up is the time it uses to come back. So this is all you need to know about this problem type, and it's very much important, and it's going to recur also when it comes to type 4 of a bouncing ball. When a ball bounces, it comes back again. So the time it uses to go up is equal to the time it uses to go down. Yeah. So now let's solve the problem to firm our understanding of this concept. So now here's our problem. It says that a ball is thrown vertically upwards. So when it's thrown vertically upwards as 10 meters per second, it returns to the thrower's hand. Ignore air friction and let the direction of motion of upwards be positive. So here they chose the direction for us, and the reason why they say ignore air friction is because they want us to deal with gravitational force only, because the situation that we are dealing with, they are like a hypothetical and are only it when there is no air friction. Because if you do it, if you throw a ball up in open air, it won't come back into the same velocity because of air friction. So that's why now we are saying that we must ignore it. So when it comes to A, it says that calculate the maximum height reached by the ball. Let's remember that they say let's take up as positive. So now what I like to do is to draw a scenario of what we are dealing with. And then let's say here's a ball, we throw it up, and then when you throw it up, it comes back to the same level or to the same hand. So we have thrown this. They say we throw it up with a velocity of plus 10 meters per second. They said up is positive, so let's just say plus 10, and then it's going to come back with what? With the same velocity, and the maximum height velocity is always equals to what? 0, because that's where it stops, because here it has no more velocity to make it go up. And then what I like to do before I continue, here I've put my formula sheet so that I can always check which formula applies. So what I like to do before taking each and every problem, I list the variables that were given. Initial velocity, are we given? Yes, it is there. It is in the information, is 10 meters per second. I list all the variables that I can use, and then let's go to the gravity. This one is always there because it's a vertical projectile. If up is positive, it means down is negative, and then it's negative 9.8 meters per second squared. It's acceleration. And then let's go to the change in y. Change in y here of the whole motion. Of the whole motion, it's what? It's 0 meters per second. But change in y from the initial position to the maximum, it won't be 0, because it moved a certain displacement from here to the maximum, but it's 0 only if it comes back, because this one will cancel this one, but this one is for the whole motion. That's why it's 0 from start to beginning. It's 0. And then, but if it is from beginning to maximum height, that's when it is unknown. And then that's why they are saying that we must solve this one. That's why they are saying we must solve this one from initial to maximum height. And then another variable that we should name is change in time. Change in time for the whole motion, we are not given here. And then the final velocity is going to come back with the same velocity but opposite sign. So this is this is what we are given, this and this and this. So now we can calculate A. We can calculate with in a different way, because this is the motion of the ball. The ball is like this, and then it comes back. It's either we can use from the end to the maximum height, or we can use this portion of motion from the beginning to the maximum height. We can calculate it going back, and you can calculate it going back, and you can calculate it going forward. It's either we use which section of motion to use, and that's why you must learn how to use sections of motion. It's either we use this section of motion to calculate the maximum height, but here, if we use this section of motion, this one, the initial velocity, it will start at the maximum height. It will be the one that you are looking for, and then the final velocity, it will be the velocity that it comes back with. But if we use this section of the motion, the initial velocity will be what? The velocity that it leaves the hand with, which we are given as 10, but the final velocity will be the velocity of the maximum height. But you must learn to use the sections of motion. Which portion should we use? The first one or the second one? And let's use this one. Let's use this one going backwards. Okay, so we are using this section of motion from when the ball is back at the thrower's end. So we are using this one where the ball is back at the thrower's end. It came back with 10 meters per second, and then here it's the maximum height is 0. I want to show you that we have to learn how to use each and every section of motion that we are given here. So let's find a formula that we can use that is distance. This one, it has time, we cannot use it. This one, we can use it because we have v final, v initial, and acceleration is given. So let's use this one. Let's remember that up is positive, and then let's work it out. Let's write down on the formula: v squared, v final squared equals to v initial squared plus 2a change in y. So v final, what is our v final? Is this one, and we must know which section of motion we're using. And when we substitute, do not forget to substitute the variable, the signs. So here the initial velocity is 0, What are we looking for? We are looking for the height. We substitute the negative 9.8, and then what are we looking for? The height, the change in y. So now this one is going to be 100, and then this is going to be negative 19.6, and then it's going to be a change in y. Divide both sides by negative 19.6, and then divide both sides by negative 19.6, and then the change in y is going to be, let me press my calculator. Okay, the change in y is 5.1 meters. It's negative. So just note that because we said up is positive, down is negative, meaning that this distance is covered downwards. It's covered downwards. The negative we changed to what? To direction. Let's see if it is true. From the section in which of the motion we chose, it's gonna be covered going where? Downwards. But if we were to choose this section of motion where it was going up, it was going to be positive, and then that positive you're going to change it to covered upwards. So you can calculate it using this section of motion of negative 10 meters per second, and then at maximum it's going to be 0, and then we are going to get the same answer using that one also. So let's go to the following question. Let me write it here so that I can clear some space. So let me, from 5.1 meters, so let me clear this space here. Let me clear this space. Okay, so it says that the time taken for the ball to reach its highest point in trajectory. So what is the time taken? So we have to know which section of motion we want to use first. We have to know which section of the motion we want to use first. Here we found that, let's just name our variables now. Negative 10 and then for a negative 10, here is gonna be 0, here is gonna be positive 10, and then we found that from here to maximum height, the height is what? The height is 5.1 meters, but the total displacement of going up, and coming back is gonna cancel, and then yeah. So now, but the maximum height it's 5.1 meters, and then what else? I think that's what we have so far. And then it said that the time taken by the ball to reach its highest point. It's either you use this section of motion or you use this section of motion. Because why am I saying that? The time taken by the ball to reach its highest point of trajectory is from here to here. Is from the initial position to the maximum height. That's the time it takes. But because we know that the time it takes to go up here is the time it will take to go back, because it behaves as a parabola, and we see that this time are equivalent. So we can either choose each of every set of motion, or we can use the whole motion and divide the time we get by 2, and then we'll just find the answer. You see, there are many ways in which we can do it here. Let me choose the one way we just start from the beginning to here, where you can pause the video and then you use the other one. But don't forget that the other one, when you substitute for the whole motion, when you substitute the displacement is going to be 0, as how we discussed in the previous. But now from the beginning to the maximum height, the displacement is going to be the distance it covers from the beginning to the maximum height. So let's do it. So let's just, which formula we're gonna use? The formula which has time. Let's use this formula, which is v final plus v final equals to, sorry, it was my problem. Let me wrap this one. And then it's gonna be v final equals to v initial plus a change in time. So when you substitute our variables, don't forget to substitute with the signs that you've chose. We are using this set of motion, so we must be vigilant of what we substitute. So our final velocity is going to be this one at the maximum. It's going to be 0. Our initial velocity is going to be plus 10. So I will say it again, we must be vigilant of which section of motion we are working with, and substitute the variables in accordance to what we are working with. And then this one, it's plus 10, when it's going to be 0, 10 minus 9.8, change in time, and then this minus 9.8 is going to come this side, change in time, and then we'll be left with 10, and then we divide both sides by 9.8, we divide both sides by 9.8, and then the answer of change in time. So 1,02 seconds. So, and then yeah, that's where we get the time. The ball, it says that the time it takes for the ball to reach its highest trajectory. Then let's go to the second one. See, it says that the total time the ball is in the air. So there are two ways to go at this one. So the time that the ball takes in the air, it's either we check the time from year to year, and then we add it from the time to year, because we see that the time it's used to go to the maximum height is equal to the time it's used from the maximum height to the final position. So if here it is here, it equals to 1,02 seconds, and then here to also be equals to 1,02 seconds, and then the total time it takes to in the air is going to be 1,02 plus 1,02, which is equals to 2,04 seconds. So now, but let's prove this by just using the whole motion. So let's just calculate the time for the whole motion to see if we'll find the same time. So now, when you use the whole motion, we have to be cautious that when we use the variables, also not the variables, the information also, we use the information for the whole motion. So if we are using the whole motion, our initial velocity will be when the ball starts to go up, which was 10 meters per second velocity, and then our final velocity is going to be negative 10 meters per second. Our total displacement, we agree that if it moves up, the distance will be cancelled by the distance coming down, and then the total displacement is going to be what? 0. And then that's what we can use. So now let's substitute the formula that has a time. We can use this formula. So let's say v final equals to v initial plus a change in time. So we just substitute. V final is what? It's negative. When you substitute, do not forget to substitute the signs, and then it's negative 9.8, and then the time is like this is gonna come, this side is negative 20, and then it's minus 9.8, change in time, divide both sides by negative 9.8, divide both sides by negative 9.8, and then our final time is gonna be 2,04 seconds. You see this one is similar to this 2,0 seconds. So you can just use the time it uses to go to the maximum height and just multiply it by 2. 1,02 multiplied by 2 is going to give us the same answer. Now, and then it says that the ball's total displacement during the motion. What is the ball's total displacement? So we agree that when it goes up, it will cover 5.1 meters, and then when it comes back, it will come back to the final position, and then this 5.1 meters is gonna cancel. So because this gonna cancel, the total displacement of the whole motion is gonna be 0, because displacement is like a final position minus initial position. So final position, if it is equivalent to initial position, is gonna be 0. So the answer here is equals to 0. Change in y is equals to 0. So this is our answer here. Change in y is equals to 0. So thank you for watching. See you later when we do this problem of problem type 3, when we do the concept and also the exam question papers.